In this video, I'm going to be teaching you guys about conditional statements in your discrete math classes. So what is a conditional statement? Well, it's represented by this little bit of arrow. This arrow that has a variable on the left and a variable on the right. And the variable on the left is the condition, and the variable on the right is what happens. So what do I mean by this? Well, we have P, it rained, as a statement, and Q, the ground is wet. So the conditional statement is, if it rained, then the ground is wet. Is wet. Now the thing about, let me fix this. The thing about the conditionals is that you're going to see the if-thens, right? If you see an if here and then a then, the if is the condition and then the then is what happens, the result, if you meet the condition. Now the thing about the truth table of a conditional is that it's a little weird. You're wondering, oh, well, how does the conditional have even a truth table? I'm just saying a sentence. Well, I'll show you. The truth table looks like this. True, false, true, true. And the only time when the conditional is false, just like a logical operator, right, and an or, is when the condition is true, but the result is false. Let me interpret this for you. So, in this case, this is our conditional. If it rained, then the ground is wet, right? P is the condition, Q is the result, and we wrote it in the order of the arrow. So these two statements, P dash Q, in the context of this problem, is equal to this sentence, right? Now, let's look at true, true. Well, true, true is basically when P and Q aren't negated. So right now, P and Q are true. So, yes, P is true, therefore it rained. And Q is true, therefore the ground is wet. So the condition was, if it rained, then the ground is wet. Well, P is true, so it did rain. And the ground is wet. So we met the condition. If it rained, then the ground is wet. Okay, I did not lie to you. This is the condition, and if it rained, the ground is wet, right? That makes sense. Now, I'm going to skip the true false because it's the only one that's false, and I'll explain at the end. But how about false true? Well, if P is false, right? So raining is false, that means it didn't rain, right? So the statement is now, if it didn't rain, if it didn't rain, fix the grammar in your head, but if it didn't rain, then the ground is wet. Now the reason why it left the ground is wet is because Q is true in this case, right? So Q is true, P is false. So that means it didn't rain, but the ground is wet. Now, the reason why this didn't break the condition is because the condition is if P, then Q, right? Well, if it rained, then the ground is wet. That is our condition, and that is our result. We didn't break that condition because it didn't rain. The ground could be wet from, I don't know, a kid spilling his ice cream, or, I don't know, you spilled your water bottle, and you broke your hydro flask, and you left a dent inside of it. But basically, we didn't break the condition. It didn't rain, but the ground is wet, but we still didn't break the condition. The condition said that if it rained, the ground must be wet. But here's the thing, it didn't rain, but the ground is still wet. So, although the ground is still wet, we didn't break the condition. There was no raining, so it doesn't have to be wet. Okay, the ground doesn't have to be wet. Now, little side note, I did this with Clash Royale terms before. And I think it was like, if you place down a prince, then you take the tower. So for those of you that play Clash Royale, maybe you can think of it in Clash Royale terms. But I thought that it was a very bad idea, especially for the people that don't play Clash Royale. You're going to be completely lost when I'm explaining these, when I was explaining Clash Royale. So I had to redo this part. But let's talk about when both P and Q are false. So when P is false, okay, that means it didn't rain, all right? And when Q is false, that means the ground isn't wet. So if it didn't rain, and then the ground isn't wet, we didn't break the condition, okay? The condition, remember, was if it rains, then the ground is wet. But here's the thing, it didn't even rain. So it doesn't even matter if the ground is wet or not. It didn't even rain. The condition wasn't met, therefore, we don't have to care about the result. The result has nothing to do with it. The result doesn't even matter. Now, when you meet the condition, when the condition isn't broken, that is when the truth table gives you a true for the conditional. So right here, the reason why we get true is either the condition was met, right? That's why true, true meets the condition. If it rained, then the ground is wet. But the reason why these two are also true is because you technically didn't break the condition, right? You didn't break the condition at all. It didn't even rain, so there's no promise for the ground being wet. It could be wet, it won't, doesn't matter, right? You didn't break the condition because the condition wasn't even met in the first place. Now, how about true, false? Well, let's try out true, false. Well, when it's true, the ground rained. It rained. The ground didn't rain, the clouds rained. It rained, okay? So, yes, this right here rained in the case of true, false. Now, how about when the ground is wet? Okay, well, in this case, it's false. Q is false, right, for true, false. So that means the ground isn't wet. Okay? If the ground isn't wet, but it rained, we broke the condition, right? The condition states, PQ states, if it rained, then the ground is wet. All right? But it didn't rain. It did rain, but the ground isn't wet for true, false. That means we broke the condition. I just lied straight in your face. And frankly, that wouldn't make sense if it rained and the ground is wet, right? And the ground isn't wet, right? If it rained and there's no roof over your head, the ground better be wet or else some magic is going on. Now, frankly, I should be studying right now and probably doing my labs for my electrical engineering classes, but I'm right here making videos for you guys because I want to procrastinate and I don't want to read that damn textbook anymore. But yes, I know, Jitty, you keep going off topic. Oh my god, you keep going off topic. I just want to watch the fucking video. I just want to watch the damn video. Go back on topic. Okay, I'll go back on topic. Calm down. All right. The next thing I have in store is completely removing sentences. You know how to interpret these conditionals in English now, but how about interpreting them using truth tables? So let's go ahead and let's make this Q negated. Ooh, that's got a little kick, right? This is kind of more difficult. It's kind of more difficult because now Q is not it. How do I write down the truth table for this? Now, here's the thing about the English statements. If you have P as one sentence and Q as one sentence, then you don't even need to care about the sentences. All you need to do is care about the logic behind this conditional, or if you want to use the AND gate, use the AND. Basically, the statements matter significantly less than the kind of math, let's say discrete math that you're doing here, right? This applied math that you're doing here. So do not worry about the statements right now. Learning the math is significantly more important, I'd say. Interpreting the sentences are probably the easiest, but let's take a look at this truth table. All right, we have the conditional, but we knotted Q now. What's the difference? We knotted Q. Well, let's write down the negated version of Q in another row. So to not true, you write down false. Let's change the color of this. Write down, let's use yellow actually. Opposite of false is true. Opposite of true is false, and opposite of false is true. So now we have not Q. So our condition is right here, P not Q. But the only time when the conditional is false is when the left is true, but the right is false. Here's the thing about Q. Q is knotted. So how do we work with this? Well, let's take a look at this. We're comparing P and not Q now. We are comparing P and not Q now. Keep that in mind. So we have not Q here, and we have the row of P here. So let's compare each one of them, right? So this right here is true, false of not Q. Therefore, the first option of this condition is false, because the only time when the conditional is false is when you have a true and false. Let's compare true, true, right? Compare P and not Q. True, true. Well, this isn't true, false, so it's true for the conditional. And how about false, false? Well, remember, if the condition is false, or the hypothesis, right? I'm using the word condition because the word hypothesis and the word conclusion, right? I didn't talk about that in the beginning of the video, but basically the condition, as I've been saying in this video, is the hypothesis, the technical term, and the result is the conclusion. Okay, I've been using those words because I thought that result and condition were a lot better terms for people that are especially not first-time English speakers. But let's look at F and T and FF. Well, if the condition is ever false, no matter what the conditional, the entire conditional will be true. It doesn't matter what the conclusion or what the result is. If it's true or false, it doesn't matter. If the condition is false, then you'll always have true. Okay, so this is the truth table for P conditional, not Q. So another way that you can interpret sentences in English for conditionals is like so. Right here, you have the result first. I'll slap you in the face. All right, that's the result. If you call me silly, that's the condition. So you could see it like this. It doesn't have to be if then first. It could be something, right? Q if P, right? So Q is the result. I'll slap you in the face if you call me silly. So, you know, there's multiple ways to say it, say these things in English, these conditionals in English. I just wanted to show you this way because this is the second most common way that you're going to see it. The other ways are just implies or like some complicated ass words. You don't have to care about those. It's usually just if then or this right here. Something happens if you do something, right? Now, keep in mind that is not an absolute. There will be cases where you're going to see this sentence in a different form, but just keep in mind if you see a condition, okay, and you see condition and you see you know, if you do something, right, then something happens, that's likely conditional. Okay. So you thought it was over. So you thought the video was over. You can go drink your coffee, drink your Monster. No, no, no. Video's not over. We're going to talk about biconditionals now. So these biconditionals, basically, instead of if then, it's not if then, it's if and only if. If and only if. Now, most of the time, you're going to see it in an English statement as if and only if. You're rarely going to see it in something different. I haven't had experiences with that. Maybe my class is just generous. But continuing on with the problem, let's write the truth table. So the truth table looks like this. True, false, false, and true. So let's write down the sentence in English and interpret how this works. So I squat 507 pounds if and only if you will give me a cake. Give me a cake. Right? How good motivation for exercising. And for those of you that don't know, I think I mentioned it in very early videos, but I haven't said it in my most recent ones. But I really like powerlifting, and I've been doing it for quite some time now. So that's why I'm mentioning squatting. Now, why is the truth table like this, right? I squat 507 if and only if you will give me a cake. Let's look at the truth table. So if P and Q are both true, then that means I squatted 507 pounds. Oh, wow, I'm really strong. And if Q is true, that means you will give me a cake after. So that means we do meet the condition. Remember, P biconditional arrow, Q is if I squat 507 pounds if and only if you will give me a cake, right? So in true, in the state of true, we did meet the condition, correct? Now how about true, false? How about true, false? Well, I squat 507 pounds, but you don't give me the cake. Oh, well, you just lied straight in my face, right? This right here is the condition and the result, and you just lied straight in my face. I'll probably give you a wet willy. Now, how about false, true, right? Oh, oops. Let's not skip past that part. If I broke the condition, then yes, the result of the biconditional is false. Now, how about FT, right? I didn't squat 500 pounds, but you gave me the cake. Here's the thing. This actually breaks the condition. Keep in mind, it's a little bit different, right? I'm saying if and only if, not if then. So it's not a single arrow. It's the two-sided arrow, the biconditional. So the only reason why you should give me a cake is if I squat 500 pounds, right? I squat 500 pounds if and only if you will give me a cake. Now, if you give me a cake without squatting 500 pounds, ooh, well, I broke the condition, right? I said if and only if in the conditional, in the biconditional, right? If I still gave you the cake and you didn't squat 500 pounds, you're probably a really good friend. right? But then again, I broke the condition here if you did, or your friend broke the condition if they gave you the cake. So that's why you get false as your logic. Now, how about false, false? Well, I didn't squat 500 pounds and I didn't get the cake. Well, technically, the condition wasn't broken, right? If I didn't squat 500 pounds, then I won't get my cake. Boo-hoo. So, although I didn't get the cake, it's very sad. I technically didn't break the condition, right? If I squat 500 pounds, if and only if you will give me a cake, right? I didn't squat 500 pounds, so I didn't get the cake. The condition isn't broken. Therefore, you get a value of true. Now, you can kind of think of this biconditional arrow as just if both the logics are the same for P and Q, then you get a true, right? So if there's false, false, then you get a true. If P and Q are different, then you get a false, right? You could think of it like that as well, rather than just memorizing the truth table or interpreting it. But this is the biconditional. And I know this video is quite long for what I explained. I'm so sorry. You could probably watch like a 5-minute video out there that explains it super quick. But I try to be as detailed as possible so not a single person misses out on what I'm saying. Right? That's the point of YouTube. I want everybody to have an easy time in school. But now that you know these truth tables, keep in mind that you're not only going to see P and Q. You might see multiple variables like R and Z as well, right? There could be four statements. All right, there could be multiple statements. And what I'm showing you inside these truth tables are super, super simple examples. So if you want to see bigger truth tables, right? If you want to see how this guy works, right? P, Q, maybe there's a negation here, ORed with a statement R, then you know the truth table for P and Q, so hopefully you can build the entire truth table for this guy right here. Now that you know this. But if you have any questions, put it in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.